We've been building microservices for the last 10 years, which is kind of hard to believe, but so be it. And it's been really interesting. I remember when microservices first came out back in the later part of the 2015, 2020. The hype went up really fast. You weren't cool as a Java developer unless you were building microservices. You had to have that listed as part of your experience that you know how to build microservice systems. And at the same time, the reputation and popularity of monoliths went down. Now, isn't a comprehensive graph or anything like that, but just kind of my general impressions is that, the hype went up and for a while, and then slowly and gradually reality started to kick in where people started getting bigger and bigger microservice apps into production and dealing with some of the challenges with that. And now lately, in the last few years, has been a bit of a backlash against microservices, and the popularity of monoliths has started to grow. It's like, which is, I think is very wise in that we should always question you when you're building some kind of an app. Should we do it with a monolith or should we do it with a microservice? There's pros and cons, of course, with each approach. But one of the issues that a lot of people ran into was the difficulties with building microservice systems, and it's like this was supposed to be easier, but it really wasn't. So why did this happen? Well, I think that a lot of the reason for some of the challenges that teams run into with microservices is what I'm calling monolithic momentum. And by monolithic momentum, I mean that even though we were going with microservices supposed to be a fundamentally different way of building apps, the tools and technologies that we're using to build these microservices didn't really change that much. And as a result, we were building often, in many cases, not everybody, but often a lot of people were building more like, not microservice systems, but more like mini monoliths. And so what I mean by mini monoliths or microliths is another common term for that. Well, it's a common form of microservice architecture where you're projecting monolithic architectural patterns and monolithic tool sets and technologies into a microservice environment. And it usually doesn't work too well. So there's two common features of microliths that I want to go into. And this is kind of a clue. Are you building real microservices or are you building or microliths? And the big clue here, I think, is tight coupling. So what do I mean by tight coupling? Well, the tight coupling is a challenge because it doesn't really work well in a distributed environment. So by tight coupling, I want to go into two patterns of what two of the really common patterns of tightly coupled microservices apps. This is the first one. This is really common. I've talked to a lot of teams that built their microservices like this. So what happened was that the code was broken up, which is great. So now we have our code off in independently deployable microservices. However, the data model didn't break up. So we have a monolithic data model, monolithic database. So this is a database type coupling. So there's disadvantages for both development and for production. One quick example on the development side, say you and I are working on a microservice and we want to make some data model changes. We're going to have to find out who's going to be impacted by these data model changes. What other microservices are going to be impacted by that? We're going to have to negotiate with the impacted changes on these data model, this new data model on these other microservices. We're going to have to come up with a kind of a more complex coordinated release of the database changes and the new versions of the services that work with these new database changes. On the production side, I think it's even worse. More often than not, in my experience, the issues, especially performance issues with back-end monoliths or microservice systems has been the database. The database is the kind of the choke point. This is where things slow down. So if the database is slowing down, it can drag down the performance of all the microservices. If the database goes down, all the microservices go down. The second form of tight coupling, very common as well, is what I'm calling remote procedure call tight coupling. And this is where the good old RESTful calls are being made from one microservice to another. This is really easy to implement and works great when everything's working well. But in a distributed environment, everything's not always working well all the time. And when things don't work well, this is where this kind of an approach can fail spectacularly. So on the development side, it's not too bad. I mean, it's relatively easy to implement this. The only downside is a bit is that microservice A, for example, needs to know something about microservice B because it's calling it. But that's not a big deal. But it's more on the production side. When you're in production and microservice A, in order for it to do some work, it depends on B. B has to be up. B has to be running. B has to be running well. It can't be slow. If B is down or slow, it affects A. And B, in this case, the call is cascading from A to B and then from B to C. Not uncommon. If something's going wrong with any one of these three services, the A depends on B and C. If anything's wrong with B and C, A is going to have a problem. So why did this happen? Like I said, it's really this kind of mono-programming pattern thinking versus distributed systems pattern thinking. You got to change the way you design and implement distributed applications. You can't project monolithic patterns into a distributed environment. It just doesn't work. But those two patterns I just showed you is really what people commonly do. Not everybody I know, but a lot of us have done it this way. So this is why I think Akka3 it really shines because, and this is why I really like it, because it has built-in loose coupling. Akka3 is designed for distributed environments from the very beginning. So going back to that first pattern, with database, the database is loosely coupled by design. You don't have a choice. When you implement microservices with Akka3, the database is controlled by Akka3. The only way to get to the data of a given microservice is through the API of that microservice. And I want to show you a quick code example of this here. When you implement you do data management, it's done through what are called Akka3 entities. This is an example of a Akka3 entity, and it's an event source entity, which is also very good for distributed system. It does event sourcing. But the thing I really want to focus on quickly here is that with these entities, the pattern is very simple. Commands come in. Commands are requests to perform some kind of state-changing operation. Then the commands produce events. So in this line that I'm highlighting right now, the onCommand method takes the command in as a parameter. It has its state, and it, based on that information, decides what events, if any, to emit. So you can see that this onCommand method returns a list of events. And then those events get persisted. This is as close as your code gets to the database. There's no database set up. There's no connections to be made in this code. There's no transactions to be done. There's no tables to define. There's no SQL to define, anything like that. This is it. It's all pure Java. And you can see the pattern kind of repeats. Command gets processed, produces events, and gets persisted. Commands gets processed, produces events, gets persisted. Now the actual business logic is not in that entity, is in what's called a domain object. And the thing I want to show you here real quickly is that first, this domain object is pure Java. You can see there's no external dependencies on anything else. So here's the onCommand, an implementation of an onCommand method. It takes in the create order command, and this is just pure Java, and what it's doing is it's running through some business logic, simple business logic, which is producing events, and then the return of this method is a list of events. Another command comes in, executes some business logic, and it returns a list of events. That's it. That's what these things do. Now, there's also event handler methods in here as well, and these methods handle the processing the events. You can see the event handler methods, the events trigger state changes. You can see the event comes in and it returns a state. So that's what's involved with handling data in entities in Akka3. It's very straightforward. It's different, but it's retooled deliberately for the realities of running in a distributed environment. The next thing I wanted to show you is RPC loose coupling. And with RPC loose coupling, the situation changes here in that the communication between services is done asynchronously. So microservice A would say is I'll show you in a minute, say is a shopping cart service. It's emitting events, and microservice B is subscribing to those events. So this is really easy to set up because it's brokerless pub sub. So you don't have to set up a broker. You don't have to set up topics. You don't have to go through any of that kind of processes built into the Akka3 platform to do these kinds of things. So asynchronous communication between services is very easy, and you can have two-way communication. So B can be a subscriber to events from A. C can be a subscriber to events from B. B can be a subscriber to events from C, and A can be a subscriber to events from B. So you can have two-way communication. It's a very common pattern to do things. Now to implement this, I'm going to show you, say, the shopping cart service where it's doing it, it's getting that checkout command. Checkout's a pretty important event. That's when we want to create an order. So the command comes in, commands converted to returns a list of events, so the list gets persisted. That's all this entity does. Another separate component in Akka3 that you implement in code is a consumer component. You can see that this consumer component in this annotation is consuming from event source entity shopping cart entity. And what is processing, you set up a method that gets past the events by Akka3. The Akka3 is handling all the plumbing for doing this. We just implement the code that handles the events. And there's a switch statement to break it down into the specific event types. In this case, we're only interested in the checkout event. So that checkout event gets converted into a create order command, and then we fire off that command to a order entity. This is how that we wire together asynchronous publish subscribe. Very simple, very straightforward to do. So the idea is that the Akka3 is engineered for loose coupling, and it's engineered in that it's got the in-memory databases where every service owns its own data, so you don't have the monolithic databases, and it's very easy to set up asynchronous communication, which is much more robust for the realities of running in a distributed environment. So I just want to leave you with this, is that Akka3 apps are easy to build the right way and hard to break. This is what I love about it. The fun part, I think, is designing these event-driven types of systems, these distributed types of systems, using Akka3. And I just gave you a quick example of some of the code, but the code is pretty straightforward. But the other really nice thing is that these systems are very robust. They're built to be strong. They're built to be unbreakable. And you get that just as a result of building these applications using Akka3. So if you're interested, you can check out to get more information at the website. I've got 2 QR codes to take you to the Akka site or the Akka documentation. I hope this was helpful. Please like, subscribe, and keep learning. We'll see you in the next one.